Hey everyone. So in this lesson, we're going to be discussing multiplication and division, but involving decimals. In the previous lessons, what we've covered is basically just multiplication and division, where for multiplication, either both of the factors have been whole numbers, or for division, um, the dividend and the divisor have been whole numbers, and then we've expressed our quotient with a remainder at the end of it. So what we're going to do in this one is we're going to change things up a little bit, and um, we're going to add in decimal points into our factors for multiplication and into our dividend and perhaps also our divisor when it comes to division. And we'll see that it doesn't actually change the process all that much. So we're going to start with multiplication. So let me put down just multiplication involving decimals. Am I going to fit this? Yes. Okay, just barely. So multiplication involving decimals. So what I'm going to do is I'm going to do one problem and show you that the answer actually works with or without the decimal point. So like we're going to do the same problem and we're just going to change where the decimal point goes. So we're going to do the same problem twice, and in one of them we'll have the decimal point and in one of them we won't. So let's say we were doing this. Let's say we were doing 1,268 times 42. 1,268 times 42. So if we do this with long multiplication, we're going to focus on long multiplication with decimals in this video, and then in the future I'll show you lattice multiplication involving decimals as well, but it works there as well. So let's do 1,268 times 42. So if we were to do this problem the way that we did it before, without any decimals, then it's straightforward, right? We've done this type of problem many times before. So we start with this 2 over here, and we do 2 times 8, and that's going to give us 16, so we put a 6 down here, carry the 1, 2 times 6 is 12, plus 1 is 13, so that goes there, carry the 1, 2 times 2 is 4, plus 1 is 5, and 2 times 1 is 2, so we get 2,536 in that line. We put our placeholder, you can put an X, you can put a 0, whatever it is that you want to put there, and then we do the same thing with this 4. So now we do 4 times 8 is 32, so we put a 2 down here, carry the 3, 4 times 6 is 24, plus 3 is 27, so that goes there, carry the 2, 4 times 2 is 8, plus 2 is 10, carry the 1, 4 times 1 is 4, plus 1 is 5, so that goes there, and then we get a line, and now we're just going to add this, and we get a 6 at the bottom, 5 over there, 5 plus 7 is 12, carry the 1, 2 plus 1 is 3, and this 5 is by itself. So we get an answer of 53,256 in this particular case. Now, so this isn't anything new, right? This particular problem doesn't have anything new to it yet. But it turns out if you change the problem by keeping the same numbers but adding decimal points, then it doesn't change the process at all. It'll only change your final answer. So the way this works is, let me see where I put the decimal points before. So instead of having 1,268, I put a decimal point right in the middle, and so I made that 12.68. And then instead of 42, I put a decimal point in the middle, and we've got 4.2. And so now, if we wanted to calculate this product instead, nothing here would actually change while we're going through this process. So I'm actually going to erase it. We're going to keep note of this answer. I'm going to put it over here. And so we've got 5, 3, 2, 5, 6. That's what we got with this first one, right? Now I'm going to erase the solution that we got. And it's actually, I mean, you're going to see at the end that it comes out to be exactly the same idea. But I'm going to erase that. And now we're going to do the same problem, but we're going to throw in those decimal points. So we're going to put in a point here, 12.68, and 4.2. Now, when we're going through this problem, while we're calculating it, while we're calculating each individual, 2 times 8, 2 times 6, all of that stuff, we're going to ignore these decimal points to begin with. So we start by going through the process exactly like we just did. 2 times 8 is 16. Carry the 1, 2 times 6 is 12, plus 1 is 13, carry the 1, 2 times 2 is 4, plus 1 is 5, and 2 times 1 is 2. So far this is the same first line as what we had before. We put our placeholder. We don't care that there's a point here. We just put our placeholder because we're moving over from the 10ths place here to the 1's place there, right? And so now we do the same thing with the 4. We can cross those out. When we do 4 times 8, which is 32, carry the 3, 4 times 6 is 24, plus 3 is 27, 4 times 2 is 8, plus 2 is 10, 4 times 1 is 4, plus 1 is 5, and that's the same second line that we got earlier. And if we just do this addition, we get the same thing, 6 there, 3 plus 2 is 5, 5 plus 7 is 12, 2 plus 0 plus 1 is 3, and a 5 like that. So we can see that these digits match exactly what we were getting before, 53256, 53256. Now the thing that changes here is that in these two factors, this 12.68 and this 4.2, we have decimals now, right? We have a point here and we have a point here. So where that's going to play in is when you're looking at your final answer. So you're going to look at your two factors, this 12.68 and this 4.2. And you're just going to count how many digits you have behind the decimal point. So basically, here in this 12.68, we have 2 digits, the 6 and the 8, that come after the decimal point, right? We've got this 6 and this 8. So we've got 2 digits after the decimal point, right? I'm not going to write after the decimal point, I'm going to write out of room. So we've got 2 digits after the decimal point up here for this 12.68. And then down here it's just the 2 after the decimal point, right? So we've got 1 digit after the decimal point in the second factor. So in total, you just want to count the total number of digits that you have after the decimal point. So we've got 1, 2, 3 in total, 3 digits after the decimal point. And so what we do is, normally if you had a whole number, this is the same as having like 53256.000 forever, right? So you could say that the decimal point is right here after the 6. And so what we do is, because we have 3 digits after the decimal point in these two factors altogether, then we just want to make sure that our decimal point has 3 digits after it in our final answer as well. So we basically take it from over here and we just bring it over 3 spots to right there, in between the second and third digits here. And so what that does for us is, if I get rid of all this in the middle, what that does for us is it leaves us with 3 digits after the decimal point in our final answer as well. And so then we can put that in over here, and we get that it's still 53256, but now there's a decimal point right there in the middle, right? And that gives us 53.256 instead. And so one thing you can do to make sure that you've put the decimal in the right spot is you can just sort of approximate with these and see, does it make sense? Does my answer make sense? If you know, so 12.68, you could say it's 12 and some change, or it's a little bit short of 13. So let's say if you prefer to work with 12, even though this number is closer to 13 than it is to 12, you're just doing a quick rough check in your head. You could say, okay, well, this is basically 12 times 4 with some change, right? So we've got 12 times 4 we know is going to be 48, and then having some change that we haven't accounted for over here, 12 and a little bit times 4 and a little bit, means it should equal 12 times 4, which is 48, and then some on top of it. So that gives us 53. Now, looking at that, you wouldn't necessarily be able to just figure out, oh, okay, it's a bit bigger than 12 and it's a bit bigger than 4, so it should come out specifically to 53. But if you already have these digits available to you at your disposal, then you can figure out which one makes sense. If you know 12 times 4 is 48, then you can just look at these digits and, okay, well, if I put a decimal point here, then I'm getting 5,000 and something. So that's too big. If I put the decimal point over here, then I'm getting 0.5 something something something, so that's not right either. If I put it here, I'm getting 530. It's just not close enough, right? We're supposed to be doing 12 times 4 with just a little bit extra, so it makes sense that our answer should fall close to 48. So that's not a way to do the problem. It would be like to just look at those numbers and sort of approximate, but it is a good way to check that your answer makes sense when you throw in that decimal point. So basically the reason that this works is that from the first case to the second case, we went from, let's see how I can write this, we went from 1,268 and we went to 12.68, which is 100 times smaller, right? So basically what we've done is we've taken this 1,268 and we've divided it by 100 to get to 12.68. Right? And then the same thing with the 42. We had 42 before, and we got down to 4.2, so we effectively just divided that by 10. Right? So we went from 1,268 to 12.68, so we effectively divided that number by 100, and then we went from 42 to 4.2, so we effectively divided it by 10. So altogether, we divided this by 100, we divided this by 10, so overall, we basically divided our whole answer by 1,000, which makes sense that if you took your 53,000 and something and you divided it by 1,000, that you'd end up with 53 point something something something. And so the way you can think of it is that when you're going through the problem with decimals there, you solve it as though there were no decimals there at all, right? So you're basically taking this number, this 12.68, and you're effectively, when you're working through the problem, you're ignoring the decimals, right? So you're not treating it as 12.68, you're treating it as 1,268. You know what I mean? So you are supposed to be solving the problem for 12.68, but you don't like working with decimals, so you pretend it's 1,268. So what you've effectively done is you've multiplied it by 100, right? And then with this 4.2, same thing. We don't want to work with a decimal, so we ignore it while we're working through the problem, and we treat it as though it was a 42, right? We treated this as though it was 1,268, and we treated this one as though it was 4.2, or as though it was 42 instead of 4.2. So basically what we've done is we've just removed the decimal points, and so in essence, you don't have to write this down and you don't have to remember it this way if it's harder. But in essence what we've done is we've taken the number that was in the question and we've multiplied it by something. We've multiplied it by 100 to get to a number without any decimals that we're more comfortable working with, and we've done that for both numbers. So effectively we've multiplied our answer that we should be getting by 1,000 if we ignore the decimal point. So if we had no decimal point there and we just got 53,256, because of all this sort of behind the scenes multiplication that's going on, we've effectively made our answer 1,000 times bigger than it should be. So at the end we have to divide it back by 1,000 to sort of undo the changes that we did before, and that's what gives us the decimal point 3 spaces from the edge, from the right edge there, in this particular case. So if trying to understand it that way doesn't really make sense, then you don't have to think about it that way. The main takeaway for multiplication involving decimals is just that that you can work through the problem the exact same way, ignoring the decimal points in the question, and then at the end, just count how many digits you have behind the decimal point in both your factors combined. So don't just count the first one, and don't just count the second one. Count them in total, put circles around them, put boxes around them, whatever helps you, and then just count, okay, I have 1, 2 behind the decimal point there, I have 1 more there, so I have 3 behind the decimal point in total, so I should have 3 behind the decimal point in my answer. So that's basically how that works. So I'm going to work through one more example for that, and then we'll hopefully get to division in this video as well. If we don't get to it in this video, then it'll be in the next video. So the next couple of videos after this one are just going to be practice questions, and then after that I'm going to put out a test review. And so your test, according to my current plan, is supposed to be next Tuesday. So if you're watching this in the week of September the 23rd, then your test will be next Tuesday, so just at the beginning of October. If that ends up changing, if you guys happen to be behind a video or two, then that can change, that's fine. But I'm going to try to leave a day for you guys to just study. I'll make a 5-10 minute test review, and then you can just use the rest of the class to study. So the next one we're going to do here is we're going to do 817.2 times 0.356. Alright, so I've tried to sort of line up the digits. Obviously it's I've put that 2 and that 6 a little bit too far with that decimal point. So put this here, 2 and 6. So we've got 817.2 times 0.356. If you don't like the 0 here, it doesn't have to be there. You could keep it like this as well. I used to sort of prefer this way, but if it's 0 point something, then nowadays I tend to prefer to do this here. When you're going through the multiplication, it doesn't really matter. You only have to go up to the end of the 3's, and then you can just ignore this 0 at the end. So let's go through it this way. And I'll keep the 0 there, but we'll end up ignoring it when we get to the end of the problem. So when we're solving this, we're basically ignoring the decimal points. We want to solve this as though it's 8,172 times 356, right? So that's how we're going to end up solving it, but then at the end we're going to consider where exactly these decimal points are, and that's going to affect the result a little bit. So let's go through it. So we'll start with the 6, and we get 6 times 2 is 12, 6 times 7 is 42, plus 1 is 43, 6 times 1 is 6, plus 4 is 10, 6 times 8 is 48, plus 1 is 49. Put our placeholder, and we can get rid of those numbers that we carried. 5 times 2 is 10, 5 times 7 is 35, plus 1 is 36, 5 times 1 is 5, plus 3 is 8, and 5 times 8 is 40, so that goes there. And then we put our next two placeholders, cross out the stuff that we carried, and we do the same thing now with this 3. So 3 times 2 is going to give us 6, 3 times 7 is 21, so the 1 goes down there, carry the 2, 3 times 1 is 3, plus 2 is 5, and 3 times 8 is 24, so that goes down there, and then we're going to add those together. So we add these together, we get 2 at the end, we get a 3 here, 6 plus 6 is 12, put a 1 up there, 9 plus 1 is 10, plus 8 plus 1, that's going to be 19, carry the 1, 5 plus 4 plus 1 is 10, 4 plus 4 plus 1 is 9, and the 2 sits by itself. So, ignoring the decimal point, we've got a number that's in the millions, right? We've got 2,909,232. But that's way too big when you consider that we're doing 817 and a little change times something smaller than 1, right? 0 point something. And that means we're going to get smaller than 817, right? If we were multiplying 817 by 1, it would give us back 817. If we're doing 817 times something bigger than 1, it'll get bigger. If we're doing 817 times something smaller than 1, it'll get smaller. So of course it doesn't make any sense that this number is so much bigger than 817. But even if you'd forgotten where to put the decimal points, you can also rule out any option that's bigger than 817 by using that logic, right? 2,909 is too big, 29,000, 290,000, all of those numbers are way too big. So if you put the decimal point too far to the right, the numbers just don't make sense in the context of the problem. But even if you don't enjoy thinking about it that way, or if you find that type of way of thinking about it confusing, then just go back to the sort of the easiest way to think about it, which is how many digits do I have after the decimal point? So we look at that first factor and we see there's 1 digit after the decimal point. And then we look at the second factor and we've got 1, 2, 3 digits after the decimal point. So it doesn't matter what those digits are, it just matters how many there are. So we've got 4 digits after the decimal point in total with those two factors. So down in our answer, we should have 4 digits after the decimal point. So from here, we move 1, 2, 3, 4, and we put our decimal point right there. So we can get rid of that. And basically what that gives us is it gives us an answer of 290.9232. And that's where it would stop. So you can always check this by plugging it into a calculator. I plugged it in earlier and I checked it against the result that I wrote down in my notes, and this is what it gave me then as well. So we got 290.9 and then some change, right? So this is sort of the easiest way to think about it for multiplication with decimals, is just ignore the decimals while you're doing all of this stuff in the middle, this stuff over here. And when you're adding them, ignore the decimals for all of that. Then at the end, just go back and count the digits behind the decimal point in both factors, and just make sure you have the same number of digits after the decimal point down here. Alright, so hopefully that makes sense. We're now going to do at least one question for division, just so you can see it. And then we might call it there, because I don't want to rush through it too much, but I definitely don't think we're going to get through more than one in this video. So we're going to go through one, and then we'll start the next video with more focus on division, and then maybe a video that's sort of a 50-50 split between multiplication and division. So I'll keep this here just for my own sanity. So let's do the following problem. So let's do, for division, we'll do 82.3. And we'll do that divided by 4. Okay, so there are a couple of different things you could face when you're working with division involving decimals. I guess I should change this title now. So this is, now we're moving on to division involving decimals, right? So there are a couple of different things you could face here. You could face a dividend, this first number, having a decimal, or you could face your divisor having decimals, or you could have both, right? So for now, we're going to focus on just the dividend having decimals, and we're going to keep the divisor as a whole number. So you could have something with a decimal here, but whatever you're dividing it by, you're dividing by a whole number. So if we wrote this out the way we did for long division before, we get 82.3 like this. We put that structure around it, and we have a 4 here. Alright, so if we just follow the same steps as before, it's actually quite similar with division and multiplication, in the sense that while you're working through the problem, you can kind of ignore the decimal points. So what we're going to do is we ask ourselves, how many times does 4 go into 8? We know 4 goes into 8 twice, so that 2 will go up there. 4 times 2 is 8, so that 8 slots in right here, and we subtract. 8 minus 8 is going to give us 0, and we bring this 2 down. Now remember, when you ask yourself here, don't forget to stick a 0 up top. For how many times does 4 go into 2? 0 times. So you have to put that 0 up there, and then if you want you can do this subtraction, but that part's not necessarily the most important. Then now the next step is you're going to pull down this 3, and this is what I mean is that here you can ignore this decimal point for now if you wish. So we'll bring that down. I'm just going to erase this a little bit and just make it a little bit smaller so that we have some room. So 0, 2, so we had a 0 here, a 2 there, subtracted a 0, left with a 2, and then we pulled the 3 down. So now we've got a 23, and we're ignoring this decimal point. I could have pulled this decimal point down here as well with the 23 and made it a 2.3, but then you'll end up confusing yourself, thinking, well, how many times does 4 go into 2.3? It doesn't. What do I do? So we ignore that, and we just ask ourselves, how many times does 4 go into 23? And we get that 4 goes into 23 5 times, so we put that 5 there, and then we're going to subtract 4 times 5 is 20, so that's going to slot in down here. So we get 4 times 5 is 20, that goes there, and we subtract, and we're left with just a 3, right? Now, here we've sort of run out of digits, but the beauty of it with decimals is that, so a number like 82.3 is the same as 82.30, right? I haven't changed anything. If you have to pay $82.3 or pesos for something, you'd never see it with just one decimal point, but that's the same as 82.30 or 82.300 or 3000, right? As long as I keep adding zeros and nothing else here, I'm not actually changing this number that I started with. So I can use that property of numbers, of having extra zeros behind the decimal point, and I can say, well, okay, if 4 goes into 82.3 some number of times, then it should go into 82.30 the same number of times, since that number isn't any bigger or smaller in value. So, because of that, I have this 3 down here, but now I've just created another digit that I can pull down, right? I'm no longer out of digits the way we used to be. So, now I can take this 0 and pull that down, and we get this 0 down here, which gives us a 30. Right? So now instead of asking ourselves how many times does 4 go into 3, or calling the 3 a remainder or something, we ask ourselves how many times does 4 go into 30, and we get that it goes into 30 7 times. So we do 4 times 7, which is 28. That's going to slot in down here. I think that 8 is extremely lopsided. 28, and we subtract that, and we're left with 2. And now we've got one last step. I'm just going to sneak it in here. So once again, we've got a 2 down here, but if 82.3 is the same as 82.30, then it's also the same as 82.300. So I can throw in that extra 0, and I can basically keep throwing zeros until I get an answer of 0 down here when I finish the subtraction. Or, as we'll see in the next video, if I can see that the pattern is going to repeat itself, that maybe I'm getting a 2, and then I pull down the 0, and the next time I also get a 2, and then I'm going to pull down a 0, and I'm going to also get a 2. That just means we're going to end up with something that's repeating up here, but we'll focus on that more in the next video. So for now, what we've got is we have this 2 down here. We just created this extra 0 over here that hasn't changed the value of our dividend, and we're going to take that 0, and we're going to pull that down as well. Now we've got a 20 down here instead of just a 2, so we can ask ourselves, how many times does 4 go into 20? 4 goes into 20 5 times, so I can put that there. I'll extend this line a little bit. 4 goes into 20 5 times, so we put that up top, and we know 4 times 5 is 20, so that can slot in down here. Try to sneak it in this space here. 20 minus 20 is 0, and so now once you get this 0 down here, now you're finished. Now you'd never have anything extra get tagged onto the end. Now we're missing one thing in this answer, and that last thing is going to finish off the problem entirely. So right now we have the number 20,575, which seems a little bit wrong, right? 4 goes into 100 only 25 times. 82.3 is less than 100, so it should be going in less than 25 times. And so what you do, it's actually quite simple. You ignore the decimal when you're pulling these digits down, but then when you get your quotient up here, this decimal point, just line it up, right? You line up this 2 up here with this 8, you line up this digit here, you line up this digit here, and this digit over here. So just line up the decimal point as well, and you're going to throw a decimal point into your quotient, into your answer, right there, just in line with the other one. So that's where lining up the numbers up on top is really, really important. So make sure you're taking care when you do that, and we'll cover that in the test review as well, hopefully. But yeah, basically you just want to line that decimal point up with this one down here. So you just look at where it is down here and then throw it in the same place up there in your quotient result. And so then you can get that 4 goes into 82.3 20.575 times. So this would be your quotient. And the nice thing with this, so we can write that in over here as our answer, 20.575. The nice thing about doing division with decimals this way is that you keep going until you get a 0 down here at the bottom, right? So here's just perhaps a better look at the end of the problem, right? So here we keep going. We started creating extra zeros over here that we ended up pulling down until we were getting a 0 at the bottom. And so if you keep doing that until you get a 0 at the bottom, you're never going to be writing an answer with a remainder per se. The remainder is contained within this decimal. So the way we were doing our problems before is we were putting in a remainder because we didn't know how to do this business with adding decimals onto that. We would have said before, we would have said, well, 4 goes into 82 20 times and then there's some remainder, right? And we wouldn't know really how to express that remainder very well. We'd say, oh, it has a remainder of 2.3 or whatever. Now, we've expressed that remainder that would have been a remainder of 2 or 2.3 or whatever it is. We express that remainder as this 0.575. That's where the remainder has gone. So it's not like it's disappeared completely. We've just expressed it as a decimal. And you'll get a better idea of this hopefully as we go along. I'm just going to do a couple of examples in the next video that involve dividing numbers by 3. And if you've ever divided things by 3 before and punched it into a calculator, you know that the decimals tend to repeat a lot when you're dividing by 3. Either you get a whole number or you get repeating decimals, basically. So we're going to explore a lot of that in the next video or two, and then you guys will have a test review after that. So this video has been a little bit longer than I would have liked, but hopefully you guys can get through it all. Hopefully I didn't confuse you with the explanations earlier for multiplication, but if you are finding it confusing, just go back and watch those parts once again, and I will cover those same ideas in the next video or two, because this is, it's not necessarily hard to grasp, but it's easy to make those little mistakes, right? When you're going through this type of a problem, it's easy to forget about that decimal once you've done all the hard work and finally gotten to the end, and you proudly state, oh, it goes in 20,000 times. Well, it doesn't, you forgot to put the decimal point in, right? So it's easy to make mistakes, so when you're doing problems, especially involving decimals for this unit, take your time with it, right? I'm not going to try and make your test on this stuff hard, because I don't want you to feel like you have to rush through the questions. I want you to feel like you can take your time and go through it at a proper pace that lets you get the correct answer. So hopefully this all made sense. I'm going to do at least 2 more videos on this just for practice problems, for multiplication and for division. One will focus more on division, and in one I'll also touch on using lattice multiplication, in case you prefer that one, the one with the boxes and the diagonal lines, and how to incorporate decimals into that, just so that you're equipped with both methods for multiplication involving decimals, and you're not forced to use one or the other. But that's it for this video. Hopefully you enjoyed it, and I will see you guys next time. Have a good one.